Okay, this video here is going to help distinguish between a paired t-test and a two-sample t-test. And by the way, a paired t-test is really run like it's a one-sample t, where here we are looking at comparing two separate means. Although this gets two measurements for everything gets two measurements, it's the average of those differences. So this is set up as HO is, our null is always set up as mu d equals 0, whereas here our HO is going to be set up as mu1 equals mu2, or the null would be mu1 minus mu2 equals 0. All right. So here we only had one mean. It just happens to mean of the differences, and the differences is what we measure twice. Here we have one mean, and we're comparing it to a separate mean. All right. Both cases are set to equal 0. So a two-sample t-test is used to determine whether or not there exists a difference between the means of two independent groups. This is really important that we use the word independent. We'll actually talk about them being independent random samples. When to use? We often want to know how two groups differ, whether a treatment is better than a placebo, or whether a treatment is this new year's resolutions work better than last year's. So anyway, we're measuring something. We're not measuring something twice. We have two separate groups that we are measuring. So paired t-test, essentially the samples are dependent and a relationship exists. Like the individual is being measured twice, or there's a before and after, but there's a relationship or a pairing between the subjects being measured. So same subject tested before and after is a paired. Same subject tested twice. In other words, they received both treatments. Tests on twins, tests on spouses, as long as you're pairing them, matching one spouse to the other, a husband to a wife or vice versa. Tests on siblings, keeping in mind it has to be one brother to one sister, or one brother to one brother and a sister to a sister, however you're going to want to do it, but it has to be a matching, a pair. All right. And just as a hint, data groups for paired data will always be the same length. They might be the same length for two sample t's, but they have to be for paired. All right. Two sample t-tests. Treatments are randomly assigned, and the average of one group is compared to the average of another. And data groups may, but do not have to be the same length. All right. But please understand, here we're taking the difference of a pair. Here we are measuring the average of one group versus the average of the other group. So an experiment measures people's lung capacity, and we're going to do this little exercise to help determine whether it's a one sample T or whether it's a paired. Because once you get that down, this is actually fairly easy work. So the experiment measures people's lung capacity before and then after an exercise program to see if their fitness has improved. Well, if we look at this, we have a before and after, so we've been measured twice, and then that makes this a paired t-test. So I would choose to use a paired. And they wanted to know how many tails. Would it be one tail or two tails? And if they say they want to improve, they're looking for an increase, so this makes it one-tailed. A difference would make it two-tailed, but since it's a direction, that makes it a one-tailed test. As a matter of fact, we're probably looking for a greater than. A different experiment measures the lung capacity of one group who took one exercise program and another group who took a different exercise program to see if a difference in outcomes existed. Here we have two independent groups. All right, so we have a two-sample t-test. All right, and we want to see if a difference occurs. Well, a difference means not equal, so that makes this a two-tailed test. The next thing, you want to see if an educational program will help raise test scores. Your experimental hypothesis is post-training scores will be significantly higher than pre-training scores. Which test would you use? All right, so we have a pre and a post, and it consequently, we would sit there and go, you know what, we can do this as paired data. That would be the best way, because you always want to do paired if at all possible. So in this case, we do paired, and we want to see if it increased. So we have a direction. So this makes it one tail. All right. Comparing the average height of men and women. Here we have two separate groups. So this is going to be a two sample, because all right, we have two separate groups. Here we're going to compare the weight of spouses. That's a pairing. So this is going to be paired data. Compare the BMI of teenagers to that of adults. We have two separate groups. So this makes this as a two sample. Comparing cholesterol levels of a child to their parent. So we have a pairing. We're measuring the child and comparing it to the parent. So this is a paired t-test. Comparing the blood pressure of patients receiving drug A to those receiving drug B. Once again, two groups. So this makes this two sample. Comparing the weight of dieters before and after a diet. They're measured twice. So that makes us a paired. So that kind of gives us a distinction between which test to run, whether it's paired data or two sample data. Please remember, one of the most challenging things is actually determining which test. After you do that, not that big of a deal. All right, I'll see you in the next video where we actually start running two sample t-tests. Thank you.